Hi everyone, I'm back with an overview of AWS's basic database services. Today, we'll start by exploring some key concepts in databases as they are the backbone of many IT systems and applications. Then, we'll also look at how AWS's core database services can help manage your data. And let's begin by looking at the two primary types of databases, relational and non-relational. Relational databases store data in columns that rows within tables, organized based on the interconnections among different elements. They're ideal for scenarios where data consistency and transactional integrity are crucial, such as in online shopping mall sites or banking platforms. Traditionally, relational databases have been the top choice for keeping data consistent and reliable. However, as data needs have grown, driven by the massive increases in data from sources like social media, IoT devices, and big data analytics, there has been an increased demand for more flexible and scalable database solutions. This has led to the rise of non-relational databases, which store information in flexible formats like key-value pairs or documents. These databases can accommodate unstructured or semi-structured data, allowing for easy scaling and efficient support of various data types. Many applications today rely on a combination of relational and non-relational databases to handle their data management needs. AWS supports this with a variety of database services, including Amazon RDS for relational databases and Amazon DynamoDB or DocumentDB for non-relational databases. This enables users to select the best tools for their specific requirements. Additionally, AWS provides managed services that take care of tasks like setup, maintenance, and scaling, allowing users more time and resources to focus on developing their applications. Now, let's explore AWS database services. So let's start with AWS Relational Database Services. Amazon RDS is a managed service that works with popular relational databases like MySQL, PostgreSQL, Oracle, and SQL Server. Amazon RDS ensures high availability with multi-AZ deployments, automatically replicating your database across multiple data centers. If there is a hardware failure, it switches to a standby instance in another zone, keeping your database running without interruption. Setting up Amazon RDS is simple. First, configure the instance by choosing the type, storage, and database type. Then, set up the master username and password for access. Next, select your VPC and subnet settings and make sure the security group allows the necessary port for inbound traffic. You can also enable automated backups if you want. Once the RDS instance is ready, you can use the provided endpoint to connect your application. Another option within Amazon RDS is Amazon Aurora, a fully managed relational database. The main differences between Amazon RDS and Aurora lie in performance, scalability, and engine support. RDS supports multiple database engines and requires more manual scaling and management, particularly for storage. Amazon Aurora, on the other hand, is specifically optimized for MySQL and PostgreSQL, offering up to 5 times the performance of standard MySQL on RDS. Aurora also automatically scales storage up to 128 terabytes and includes built-in high availability and fault tolerance by replicating data across multiple availability zones. Typically, Aurora costs more, but it is ideal for applications that need high performance and easy scaling. Setting up Aurora is similar to RDS. Choose between MySQL or PostgreSQL and configure the instance size, storage, and security options. Aurora then handles replication, backups, and scaling automatically, ensuring consistent performance and availability. Now, let's look into non-relational database services in AWS. Starting with DynamoDB, it is a serverless, fully managed NoSQL database service that eliminates the need for server management and software maintenance. It automatically scales to handle varying traffic and charges only for the read and write requests used. With single-digit millisecond response times, DynamoDB provides fast performance and supports key value and document data models using a denormalized data model for better efficiency. DynamoDB also takes care of all database management tasks, including setup, security, backups, and monitoring. Another non-relational database is Amazon DocumentDB. It is also a fully managed database service for storing and managing JSON documents, supporting MongoDB workloads. JSON documents use a simple text format with key value pairs, making data easy to read and write. DocumentDB efficiently handles large volumes of this kind of data without requiring server management and offers built-in security, automatic backups, and integration with other AWS services. Additionally, it supports artificial intelligence, AI, and machine learning, ML, to help with analyzing and managing semi-structured data. For applications that need to handle highly connected data, like social networks or recommendation engines, you may consider using Amazon Neptune, which is a fully managed graph database service. It is designed to easily scale and stay available. It comes with built-in security, continuous backups, and works well with other AWS services as well. Neptune Global Database allows data to be replicated across different regions, which helps with fast data access, disaster recovery, and scaling for global applications. How it works is, Once data is loaded into Neptune from Amazon S3, where parallel bulk loading for CSV and RDF data is supported. It can be queried using various Open Graph APIs, allowing to efficiently navigate and interact with highly connected datasets. If your application requires fast data retrieval, Amazon ElastiCache provides a fully managed in-memory data store that supports Redis and Memcached. A cache is a temporary storage area for frequently accessed data, enabling much faster retrieval compared to accessing data from the main database. This improves the performance of your application. So, Amazon ElastiCache is ideal for caching, session management, and real-time analytics. By storing data in memory instead of on disk, ElastiCache significantly speeds up access times, making ideal for applications where quick data access is crucial. Amazon ElastiCache charges based on the resources you use, including node type, memory size, and data transfer. Now, let's look at the data warehouse service provided by AWS. A data warehouse is a centralized repository that organizes and manages data from multiple sources, making it easy to search and analyze quickly. Amazon Redshift is effective for analyzing massive amounts of data, particularly at the petabyte scale. It is suitable for real-time analytics, helping companies make quick decisions based on both current and historical data. Redshift also supports business intelligence by allowing users to easily create reports and dashboards, and is useful for log analysis to understand user behavior. It can handle various types of data, structured, semi-structured, and unstructured, where traditional tools might struggle. However, for traditional data warehousing and larger scale storage needs, S3 data lakes may offer better data storage flexibility and cost efficiency. Amazon Redshift charges based on the instance types, data storage, and data transfer used, with options for on-demand or reserved instances. So, it's a matter of choice. AWS offers two tools for database migration: Schema Conversion Tool, SCT, and DMS, Database Migration Service. SCT converts your database schema to a format compatible with your target database. After setting up this schema with SCT, DMS manages the data migration. So start by creating a replication instance in DMS to handle the data transfer. Then connect your source and target databases. Then set up a migration task to specify the data to be moved. While DMS is primarily for relational databases, it can also handle some non-relational ones like Amazon DynamoDB. DMS ensures minimal downtime and real-time updates during migration. Charges depend on instance type, data transfer, and storage. And after migration, monitor the process to confirm that all data is transferred accurately and the new database is functioning properly. Megaton Cloud has a team of specialized engineers who can assist with selecting the appropriate database type and size, as well as guiding you through the overall migration process. So please feel free to reach out to us at any time. Alright, in this session, we explored relational and non-relational databases, which are crucial in today's data-driven world. We also covered various AWS database services that cater to the growing volume and complexity of data. This concludes our Easy Cloud series. I hope this session has provided you with an understanding of basic cloud concepts and core AWS services. We'll return with more interesting and helpful sessions, so stay tuned. Thank you very much and goodbye.